All right, welcome to statistics. So we're going to talk about the pretest for, or the test two pretest here. So what I have here is I have a bunch of paper, a bunch of stuff I can write on, and we have our pretest sitting right here. Now, if you don't mind, what I'm going to do is I'm going to go ahead and write down some of this stuff on my paper because my vision currently stinks. So it's hard for me to see what's going on here. So we're saying determine the probability of selecting an eight from the hand of cards shown. So the idea is here we have a hand of we have a pile of cards and we don't know what they are. So we're going to say that, good Lord, I don't want any of this. Stop it. Um, Here we go. So we got a pile of cards. We have an eight. Okay. We have a queen. We have a three. We have a six. We have an ace. We have an eight, and we have an ace. All right. And that's pretty much looking at what we have here. So they're asking us, okay, what is the probability of drawing an eight? Okay. So we're trying to draw an eight. So here's what we're going to do. There's one, two, three, four, five, six, seven cards. So my n is equal to seven cards. How many eights are there? Like, well, there's two eights, right? So we're going to say the probability of drawing an eight out of this hand, provided you can't see them. Okay, if I just shuffle them and like spread them out in front of me and say, okay, what's your probability of drawing an eight? We would end up with two sevens. Okay, and that's pretty much all you're trying to do with that. Um, they don't need you to do any kind of arithmetic. They don't need you to punch it into a calculator. They don't want a decimal. They, I thought they would want. Oh, I guess they do want a decimal. Okay, well, my mistake. All right, so they wanted to round to the nearest hundredth. Ah, there we go. So we need to go to the point zero x kind of a problem here. All right, so the calculator that I have is this guy right here, mostly because I can show it to the whole screen. Okay, so we're just going to say we have two, come here, 2 divided by 7 equals, and I'd say, okay, to the nearest hundredth, this is 0.2857. So usually we like to draw these things 0.2857, and I usually like to go four decimal places because way back in the day, there used to be something called CRC books, and like the normal distribution numbers that you have, they'd be published and you'd have to go look these things up. They always went to four decimal places. So I'm used to everything going to four decimal places. In this case, we only have to go down to the hundredth. Now, I'm looking at the thousands, right, one step further. It's a five, so we're going to round this thing up. So we end up with 0.29. So that's what we're going to go ahead and deal with. Okay, so we have 0.29 here. Let's go ahead. You can go away. So we have 0.29. If you just type in the 0.29, Alex will take it, but it will yell at you. It's like, you should write a zero for your leading zero. Okay, hooray, we got the right answer, and we can go on to the next problem. Okay, continue. All right. So suppose that 10.2% of all humans are left-handed. All right. What is the probability that the next person you run into is left-handed? We're going to say, okay, we have to convert this from 10.2 to a decimal place. You guys have done this before. So we have 10.2%. We're just going to change the decimal place and it's going to be 0.102. And that's going to be our value for decimals for this thing instead. Okay, so we'll just go with that. We'll say 0.102. All right, you don't have to write that in. So we'll go ahead and we'll say check for that part so we can see what's happening. Like, hooray. And then the next thing we're going to do is say, okay, what is the probability the next person you run into is right-handed? And we're going to make an assumption that there are no ambidextrous people. It's a terrible assumption. Okay. And what we're going to do is we're just going to say we need 1 minus 0.102. So we're going to say, okay, 1 minus that, that's going to be 0.900 minus the 0.02, that's going to be 0.88 or we're just going to do this the hard way. Okay. So we're just going to subtract 1,000 from 102. So we can go ahead and say that's going to be a 9, 9, 9. Thank you very much. So we have 10 minus 2 is 8. 9 is 9 minus that is going to be 8. And we have 0.898. Okay. So just to make sure that I can't do arithmetic, there we go. You guys will have a calculator at all times. So this is not a thing that you have to worry about too much. So 898, and you're all set. Okay, let's go back up to here. We have 0.898. How about 898? 898. Assuming I can type. Okay, then we'll go ahead and check that guy off. Okay, correct. What happened with that? Oh, point. I forgot the decimal place. 0.898. Okay, recheck. All right, there we go. Be careful. Okay, we'll go off to the next problem, problem number 3. So let's see here. What is the probability that a person who was, okay, so we have 493 out of 1608 people said that they prefer to sleep in on Saturday mornings. Great, who doesn't? So what is the probability that a person who is polled prefers to sleep in on Saturday mornings? So we're going to say that this is going to be really what we want to do is we want to say 493 out of 1608. We're going to go ahead and calculate that out. So on a calculator, because I am not going to do long division to figure this out. That's not going to happen. But fortunately, we have calculators. Okay, so we have 493 divided by, what is it, 1608 equals, come on. And then we have to go back and check, like, okay, round your answer to 4 places. Fantastic. We're back to normal. 0.30659. Now we're rounding this. So this is going to go up because we have 1, 2, 3, 4. We want to get rid of that. So it's 0.3066 because we have to round it. Okay, and that's what we're going to go do with that one. So 0 point. Where do you go for your answer? Okay, there you go. 0.30. And then I've got to go double check 3066. 6, 1. There you go. We'll check. All right, hooray. Interpret this probability by estimating the percentage of all people before to sleep in Saturday morning. So we're going to pretty much do the same thing. We had 0.3066. What we're going to do is move the decimal place over twice. So we have 30.66%. What did they want us to round this to? Round your answer to 2 decimal places. So it's just going to be 30.66. Okay. Like, that's kind of an easy problem. Like, that's okay. They don't all have to be the hardest problem I can think of. Okay, so it's if you're kind of hanging on by your fingernails and this is kind of a tough class and you're having a tough time with it, not every problem is the hardest problem you can look at. Okay. That's the way it should be. So let's see. Medical treatments. Let A be the event that a patient requires an antibiotic treatment. B, let S be the event that the patient requires surgery. A for antibiotic, S for surgery. Suppose that the probability of A is 0.09, probability of S is 0.1, and the probability of A and S is 0.06. Find the probability that the student needs any kind of a treatment, either antibiotic or surgery or both. So this goes back to way back when we are looking at probability of A union B. This was equal to probability of A plus probability of B minus probability of A and B. All right, and that's what we're going to go figure out. So we have to do both of them. So this is what we're trying to figure out here. So we want 0.09 plus 0.10, right? That's 10%, minus 0.06, and that's what we're going to go ahead and sort out now. Okay, so I'll go back to my calculator for a moment here because I don't want to take the risk of making a mistake. So we have 0.09 plus 0.10 minus, what do we have here? 0.06. Okay, you don't have to put all the zeros in, it's fine. We'll go ahead and say that. We'll have 0.13. Okay, so this is called inclusion-exclusion rule, right? So you add up all the things and you subtract out the intersections. And that's what we're going to do with that. Okay, so let's see here. So we have 0.13. Okay, 0.13, and we'll go ahead and check on this guy. Okay, fill in the, oh, I have to do both of them. Find the probability that the patient does not need surgery. Okay, so we don't need surgery if it's going to be 1 minus. So we know 1 minus 0.10. Okay, we can do it out on here, but we're going to say 1 minus 0.10 that I can do, right? You have a dollar. You just give it, if you something costs a dime, how much change do you get? We get 90 cents in change. Okay, so we can go ahead and sort that out. So we have 0.90. So 0.90. All right. We'll go ahead and check this guy, say hooray, and there we go. Okay. What did it out like? Your answer is correct. However, oh, you don't need to put it was okay. Usually, if there's one that's two decimal places, I'm going to make them all two decimal places because I think in dollars and cents because my first job out of high school was being a cashier, and I did that for a number of years. So I usually think in dollars and cents here. Continue. This will be the last one for this video, and we'll keep going with this. So, how good are your grades? Hopefully, they're great. In a recent in a recent semester at a local university, 600 students involved in both statistics and psychology. Of these students, 71 got an A in statistics, 61 got an A in psychology, 41 got an A in both. And then we're going to go ahead and round some things, round the answers to four decimal places. So when we go ahead and figure this out, find the probability that a randomly selected student got an A in statistics or psychology or both. Okay, so we're going to go ahead. We need to know. We want the probability that you got an A in statistics, or I'm going to go ahead and use the Greek letter psi because when I had a friend that took statistics, that was his favorite Greek letter because that's the PSY letter. Okay. And we're going to say that that is the probability of S plus the probability of psi minus the probability of S intersect psi. Okay. S will be an A in statistics, psi will be an A in psychology, and then we'll go ahead and figure this out. Okay. So again, inclusion, exclusion rule. We add them both up and we subtract out the intersection, right? In both, that's the intersection. So we can go ahead and say, okay, what are we doing with this? We have to go back up to the preamble here. So we're going to say we have 71 out of 600, okay? Plus 41, no, sorry, not 41. So we have 71 plus, where is there it is, erasers. Okay, so we have 71 plus 61 got to say an A in psychology, so 61 out of 600 minus, and then here we have 41 over 600. And I know when you're looking at the fractions, you're like, fractions are scary. I don't like these. You're allowed to convert them to decimals. But before we do that, hey, these all have the same common denominator. Can I just add these? Like, yeah, sure you can. So 71, 61 minus 41. So I'm going to do that first so I can get the numerators, and then we'll figure out the denominators from there, okay? So we're going to say we have 71 plus 61, which is going to be that, minus 41. So we end up with 91 that we're dealing with. So 91 over 600. So we'll go ahead and just sort out that. So we have divided by 600, enter, and we have to go to four decimal places. So that's going to be 0.15166667. So this is going to be equal to 0.1516 repeating. Okay. So 1, 2, 3, 4. We're going to go ahead and round this one because it's a 6. We're going to round it up. So we end up with 0.1517. That's my answer that we're going to say for this guy here. All right. So here we go. 0.1517. Okay. And again, you don't need the leading zero. But if you are taking any kind of science classes, you should put the leading zeros in because this is the proper way to do it. And especially if you're in nursing, if you're in any kind of allied health thing, decimal places can cost you lives. So we're going to put this leading zero in there so people know where the decimal place is. All right. Next one. Find the probability that a random chosen student did not get an A in statistics. So all we have to do is say 600 over 600 minus, what did we say for statistics? That was going to be 71. 71 out of 600. So again, we still have the same common denominators. We're just going to take 600 minus 71. Okay, and again, all divided by 600, and we'll go ahead and sort out what that is. All right, there we go. So we're going to say we have 600. How about 600? 600 minus 71. We have 529 over 600. 529 over 600. So we'll go ahead and sort this out. So 529 divided by 600, press enter. 0.881, again, 66667, so it's going to say 0.0881. And since this keeps going, we want to go to 4 decimal places, 0.8817, and that's going to be our answer for this guy. So 0.8817 for this problem. Okay, so 0.17, and that's what we're going to go ahead and, oh, you have to type it into the book, not into the calculator. Calculator doesn't care. Okay, so let's see here. 0.8817. Was that the right? Was that the answer I got before? 8817. So we'll go ahead and we'll say check. All right, hooray, we're okay with doing this. And hopefully that was helpful to you guys. I'm going to stop here at 5, okay, so that we can do that. And I will see you in the next video. Thank you very much for watching, and I'll see you in the next one. Take care.